Hi everyone. Today we're going to learn how to expand or condense log expressions. We're going to learn about some law of logarithm here, and we're using them to simplify log expressions. The first law that we're going to learn is called product law. If I have log of a plus log of b, I can rewrite that as log of a times b. So that means, first of all, remember, keep in mind that if you have log expressions here, they all should have the same base in order to be able to use this law about those log expressions. So here, I don't see any base. That means their base is basically 10 for all these terms. Anyway, if I have log of a plus log of b, I can rewrite that as 1 log and then multiply the two arguments together as the new argument for this log. So here's one example. I have log of 5 base 8 plus log of 4 base 8. So notice the bases are the same here. So I can rewrite that as log of 5 times 4 base 8. And we know 5 times 4 is 20. So that's log of 20 base 8. So let's do these examples. We have one log here, log of 8x, y. We want to expand this into several logs and change them to addition or sum of few logs, basically. So since I have 3 factors here that are multiplied by each other in this product, so I need to write this as 3 different logs. So that's going to be log of the first factor plus log of the second factor, which is x, plus log of the third factor, which is y. So this is how you expand this expression. Now, the next example that we have here is going to condense. We have 2 logs and we want to condense that into 1 log. So I'm going to rewrite this as 1 log and multiply the arguments 3a times 8. And we know 3 times 8 is 24, so this could be written as log of 24a. So that's how we condense and we change the 2 logs, the sum of 2 logs, into only 1 log. The next law that we're going to learn is called quotient law. If I have log of a minus log of b, so 2 logs with the same base subtracted, I can rewrite this as 1 log and divide the arguments to each other. So the first one is going to be on top of the fraction. The second one will be in the bottom of the fraction. So look at this example. Log of 12 minus log of 2. The base is 10 for both of them. And I can write this as log of 12 divided by 2, which is 6. So that's going to be log of 6. So we're going to do this example. Log of 2x over y. So we want to expand this one. So for expansion, basically, we're going from the right side of this equation to the left side. Right side of this law to the left side. Since there is a division here, a fraction, I can rewrite this as 2 logs subtracted from each other. So I'm going to write log of the top, that's going to be the first, minus log of the bottom. So that's how I expand, but there's one more step here to expand, basically. Log of 2x, that's multiple of 2 factors. So I can use basically this law, the product law. From the right side, I'm going to move to the left side. So I have log of 2 factors multiplied by each other. I can rewrite them as log of the first factor plus log of the second factor. And I'm going to rewrite the last one, log of y. Now, the next example, we want to condensed into one log. We have subtraction between two logs, so we're going from left to the right side. And I can rewrite this as log of the top over the bottom. So that's just log of 9 over x. Next law is called the power law, basically. So if I have log of an exponential, like a to the power of n, I can move the exponent to the front of the log and rewrite that as n times log of a. Again, this rule, like the other ones that we just talked about, is a two-sided equation. So I can go from left side to the right side or right to the left. So here's this example. If I have log of 5 to the power of 3, I can rewrite as 3 log of 5. That means I can move the 3 to the front of the log. So here's another example, log of y to the power of 5. Move the 5 to the front of the log, and this could be 5 log of y. And here, I want to condense, basically, have a number multiplied by my log, so I can move this as the exponent and write that as log of x to the power of. So the first one was expanding, the second one is condensing. Move the coefficient of the log to the top here as the exponent. The next rule that we're going to learn is called change of base. So in this example, I have log of a with base b. I can rewrite this as log of a with base c over log of b with base c. So I choose any other base that I want, and I can rewrite that as a fraction, as a division of two logs with the new bases that I choose. So here's this example. I have log of 8 base 64. Let's say we don't know what is the answer of this log. That means I don't know what is log of 8, 64. I don't know 64 to the power of what number is equal to 8. So I can use the change of base here to easily find this answer without a calculator help. So I'm going to change this to 2 logs divided by each other, and I'm going to choose base 2 here. So let's say the base is 2. So now I can easily find the answer because I know log of 8 base 2 is 3, because 2 to the power of 3 is 8. And log of 64 base 2 is 6, because 2 to the power of 6 is 64. And I can simplify this as 1 over 2. So as you see, I use this rule to basically evaluate this log without a calculator. Here's another example. I have log of 25 base 7 over log of 5 base 7. This time we're going from the right side of this equation to the left side. So since evaluating this expression is not easy for me because I don't know 7 to the power of what number equals 25 or 7 to the power of what number equals to 5, I can condense this into one log as log of 25 base 5. So you see the argument of the top will go here as the argument of the new log, and the argument of the bottom is going to be here as the base. And I got rid of these two bases. I don't need them anymore. So that's just log of 25 base 5, and that's equal to 2 because 5 to the power of 2 is equal to 25. So these were a few rules that we use to simplify log expressions. And now we're going to practice them here. This example, we have log of x to the 3 times y times z to the 7. I'm going to expand this. I write log of x to the 3 plus log of y plus log of z to the 7, because there were 3 factors that were multiplied by each other. So I can use the first law to expand to sum of logs. I can expand this one more step because there are exponents here. I can move the exponents to the front of the logs. So I can write this as 3 log of x plus log of y plus 2 log of z. So that's how I expand this problem. Now, the next one, I have log of a division, basically, a fraction here. So we know we expand fractions into subtraction. So I can rewrite this as log of 2a to the 3. You may put parentheses or not, it doesn't really matter, minus log of 7b to the power of 5. So log of top minus log of the bottom. Now I can expand this one more step because this is 2 times a to the 3, so it's a product. So I can rewrite this as log of 2 plus log of a to the 3. So the first one expanded into this. Now the second one, again, could be expanded into two different logs because it's 7 times b to the 5. But I'm going to put the parenthesis here first because this negative belongs to this whole thing. So if this is expanded, the negative is behind the whole expanded term. So that's going to be log of 7 plus log of b to the power of 5. Now, I can expand this one more step because I have powers here. I'm going to move them to the front of the log. So log of 2 plus 3 log of a. So we're going to move the 3 to the front of the log. And then I can also move the 5 here to the front of the log, but also I'll keep in mind that there was a negative here. So I have to distribute the negative into these two terms as well. So that's going to be minus log of 7 minus 5 log of b. So that's the expanded. There's one thing that we need to remember. If I have radical b, that means it's basically second root of b, and there is a power of 1 here over b. I can rewrite this as rational exponent as b to the power of 1 over 2. Third root of b can be written as b to the power of 1 over 3. And nth root of b to the m can be written as b to the power of m over n. So we're using this to expand log expression. We'll see how it works here. So I want to expand this log. First of all, there is a division, so I can rewrite that as subtraction between two logs, difference of logs. So that's log of 2a, log of top, minus log of the bottom, which is third root of b to the power of 5. So I know this one can be expanded into sum of two logs. So log of 2 plus log of a. And the second one, I know that based on what we just talked about, I have third root of b to the power of 5. I can rewrite that as b to the power of 5 over 3. So this number goes to the top, the index goes to the bottom. Now I have an exponential here, and I'm going to move this power to the front of the log. So I'm going to rewrite as log of 2 plus log of a minus 5 over 3 log of b. So now this is x. The examples that we have on the second page, this time we're going to condense them into one log. So we want to simplify each expression as one single logarithm. So always when you want to condense, look at the coefficients of the log. So first of all, look for any log term that has a coefficient behind that. Those are basically the exponents that had been moved to the front of the log. Like this 5 was basically here. So we're going to move it back to the exponent. In order to condense, I'm going to write log of 2 plus log of x to the power of 5. So this is the first step. The second one, since I have sum of two logs, I'm going to use the product law again, but this time I'm moving from left to the right. That means I can write this as log of 2 times x to the power of 5. So I I condensed this into one log. Let's look at the next example. First of all, as I said, we're going to look at the coefficients of log and move them as the powers. So that's going to be log of 14 plus log of x to the power of 10 minus log of y to the power of 5. Then we're going to look at the first two terms. They are two terms added together. So I can use the product rule and say this is log of 14 times x to the power of 10. So move from the left to the right and look at the term. And the next one is log of y to the power of 5. Now I have two logs subtracted, so I can write this as log of 14 x to the power of 10 over y to the power of 5. So we use the quotient rule here. Now we have only one log. Next one here, again, look for the coefficients first. So move them as the power. So I'm going to write log of x, and I'm going to follow exactly the same order, and everything that I have here, I'm just going to copy them. I have a minus and a parenthesis, so I'm going to keep that. And then write log of a to the power of 5. So that's going to be log of a to the power of 5 plus log of b to the power of 3. Now, the two log expressions that are here are going to be written as one log. So that's log of a to the 5 times b to the 3. Since I had a parenthesis, that's why I did this one first. And then I'm going to rewrite the first term. Now I have two logs subtracted from each other, so I'm going to write as log of x over a to the 5, b to the 3 as a fraction, because there was subtraction here. Okay, let's do the next one. Again, look for the coefficients first. So the 8 here is a coefficient moves to the power, and the 2 also here. But I'm not going to do the 4 yet, because this 4 is behind the 2 log. It's not behind only one log. So I'm going to keep this here for now. Write 4 bracket log of x base 5 plus log of y to the power of 8 base 5 minus log of z to the power of 2 base 5. Now the two logs here can be condensed into one log using the product rule. So that's going to be log of x y to the 8 base 5 minus log of z squared base 5. Now I can move the 4 to the power of this argument, like this whole argument. So that's going to be log of x, y, 8 to the power of 4 minus log of z squared, and base is 5. And since I have subtraction between two logs, that's going to be log of x, y to the 8 to the power of 4 divided by z squared. This whole thing is our argument, and the base is 5. Now, the last one, I can do different things about these. I'm going to start with moving the coefficients first. So I have 1 over 3 log of a to the power of 12 minus log of b minus log of to the power of 1/2. These two can be written as fraction. So that's 1/3 log of a to the 12 over b minus, if I have a power which is fraction, I can rewrite that as square root because the base is 2, so square root of c. Next, I'm going to move the 1/3 as the power of this fraction that I have, this argument that I have here. So that's log of a12 over b to the power of 1/3 minus log of square root of c. Next, if I have a power of 1/3, I can rewrite that as a radical with index 3. So that's log of third root of a to the power of 12 over b minus log of square root of c. And now I have subtraction between two logs. So I'm going to write that as a division. Log of a12 over b, third root of that, divided by square root of c. So this whole thing is our argument. And we know that if you don't see the base was base actually 10, but you don't have to write it. So that's how we condense into one log. This was today's lesson. Have a great day.